Okay, so photogrammetry is really in vogue and people are using photogrammetry, but they are not using the word photogrammetry, which is a shame. Drone photogrammetry. So the drone is only a platform. The concept is the same. It's the concept of photogrammetry that is being applied. Just as people have designed these drones. The drones have been there for years. I think we have very big drones that America used to, during the Iraq War, I think they were dropping some bombs. They use a drone, like you send an airplane without a human being so that if you bomb it, they don't care. Nobody's in there. Are you okay? And so we have these platforms, this equipment that allows us to, instead of using a drone, excuse me, you can actually use a helicopter. I'm sure you've seen a helicopter before, haven't you? So you put a camera under it, in the belly of it, excuse me, okay? Or you can use a biplane twin engine to do that, but it doesn't matter. These are quite old, isn't it? So you simply put a camera under it. These are looking very, very old. Anyway, sorry, I don't want this one. All right, World War One. Hey, I'm going far. All right, so but then bottom line is that you should be able to fly on top of an area and take pictures. End of story. That is what photogrammetry is all about. And then you carry through a process. The photogrammetrist knows what to do. Okay, if you're not a photogrammetrist, you may not understand. You get a picture at the end of it. You get what we call a digital elevation model. Very nice thing to have. Are you okay? Can measure from it, can map it, can digitize it. Are you okay? But it's really a picture you get. So one of the questions you normally get in the exam is, what do you get at the end of photogrammetry? Then, people try their luck, what do you get at the end of photogrammetry? Someone will just say what they think, clockwise. Okay, so the next one is GPS. So who knows what GPS is? Who can tell us? Or I should tell you. No time wasting. I think we are all hungry. Let's do this. All right. So GPS is actually global positioning system. So when someone asks you what is GPS, don't be saying something else. Are you okay? It's geographical. People write all sort of things if they are asked what it is. It actually stands for global positioning system. In some phones, they don't write GPS. They actually write location. But then they are referring to GPS. That's the only way you can measure a position without using measuring distances and then angles. In fact, it's not easy to locate something on paper. You'll be shocked to know that. Unless you're using surveying methods, it's going to be very difficult. Is that okay? So global position systems have come initially, you have to mount it. The receiver, I'll talk about receiver and then the transmitters. So let me tell you, the basic thing about global positioning systems is that I'll tell you what it does, and I'll tell you exactly how it works. It allows you to position yourself pretty precisely. Is that okay? What do I mean by that? It means I can tell where I am. You see, which is not an easy thing to do. You may think what I'm saying doesn't make sense. But if someone, like were somewhere and they were lost in the forest. In fact, there's a story that is told of two couples that actually went hiking and then they got missing and they got lost. They realized that they didn't know where exactly they were. So they were walking around on the mountains on some plateau. Someone mentioned plateau. And they saw, some human skulls and bones, and they were a bit worried. They were like, let's go closer, let's find out. Then closer to it, they also found a sheet of paper. And on the sheet of paper, the notes, it was a note. And they said that we were trying to find our way out. I was trying to find my way out. I couldn't find my way out, So obviously the couple knew that they were in deep trouble because they got missing, you know. So if you got missing like that and you had a GPS receiver on you, have a phone with a GPS, then you could then appreciate why we say it's a precise navigation tool. Okay, you can find your way back home easily. Now, GPS actually it was termed that way by the US Department of Defense. Is that right? But other countries have also tried to have their own GPS systems. It's simply satellites in the sky. So how do you get satellites in the sky? A rocket takes it, yeah, it puts it on, it's put onto the rocket as a module, and the module detaches itself when the rocket has reached the space, outer space. Okay, outer space means it leaves the Earth's atmosphere, even though some satellites also fly quite close to the Earth's surface. Is all right, quite close to the equator, etc. So anybody who can do that can now and empower those satellites to have receivers on it that send signal to the Earth, can then compute a location if there are receivers on the ground to receive those signals. That's how GPS works. So what signals are those transmitters on the satellite sending? They are sending data about their position. Are you okay? And mathematically, you can determine the position of a place, a location, if you know the location of about 2 or 3 other points. Is that okay? So it's called resection. Is that right? So that resection is done. That's how your phone, anytime you switch on your phone and you are doing this Google thing, remember that calculation is happening. As an engineer, know that your kid will ask you one day, Daddy, how does this work? And you'll be in trouble. So other countries, well, this kind of power struggle, people also thought, hey, we need to do our own because otherwise the US is going to take over the world, that kind of thing. I'm not telling you history, but basically that is how come I think Russia's got their own, Europe has their own, China has their own, even India has our NSS, Japan also have their own. All right. Hey, today this thing keeps turning on. What's going on? Anti-clockwise. All right. So that is it with global positioning systems. The diagram you see on the board, stay still, shows what I'm talking about in pictures. Okay? So you can see clearly that these are receivers on the right hand side. Is that okay? And this is conceptual. The Earth is in the middle and then it's going around it. That's a nice picture to explain to you how it works. Over here, same thing, receivers, and then we have the satellite. The satellites have the transmitters mounted on them. And then we have another picture. This one is an animation. It shows you these dots. These dots represent satellite positions. And then the lines you see are called orbits, not orbits, orbits. Is that okay? So orbits, these are circular paths that the satellites take. Is that right? Okay, trying to clear it up. Orbits. Okay, have so many applications. People are using GPS for fishing, for a whole lot. All right, but it can be used for engineering purposes, can be depending on the method used. But basically, there are 3 segments of the GPS. The user segment is those who use GPS, maybe for navigation. That means that flying from Accra to New York, GPS will really help you. Control segment controls the satellite. Look at the satellite health, the health of the satellite. Space segment is the satellite itself. Are you okay? So Colorado Springs is one of the places where you have the control segment. All right. Basically, you can have 24 satellites and you have 6 orbits. Then you have 4 satellites in every orbit. And then you can, everywhere you are on Earth, you can get a position. So that is why we call it the global. The word global means everywhere you are. All right, so how far is it? It's about 11,000 nautical miles. So think about a nautical mile to be almost twice, okay, excuse me, a kilometer. So 2 kilometers is about 1 nautical mile. So if you have 11,000 of that, keep going, 100 nautical miles, you can imagine where you'll be. Okay. So from Kumasi to Accra is like 200 kilometers. Okay. So that means that is how many nautical miles. Okay. So you can do that calculation for yourself. All right. So here we go. Yeah, more pictures, user segments, space segments. Students need to know these things. Yeah, every student needs to know some things. It's basic. All right. We will get coordinates. I told you that you are trying to get your position, location. That's different from I'm flying and I'm taking pictures. There are two different things you get. One of them gives you where you are, X, Y, Z. That's GPS. And then photogrammetry is giving you a picture of a larger area. Please, these are the basic things a student should know. Don't think further than that, please. Because I'm not going any detail than this. I'm just touching the surfaces on some of these methods. Remote sensing is like you're doing photogrammetry and you decided that, okay, I don't want to actually, take the pictures over a small area. I want to take it over a larger area. So I want to take my airplane height far higher. So that is when remote sensing comes in. So remote sensing also makes use of satellites, except that these satellites are not sending their location. They are rather taking pictures. I hope we understand. Okay, so I'll ask for questions for now. I'll ask some questions. Please ask questions for me so that if it's something that you want to ask question on, I'll talk about it. Yes, go ahead. Mention him.
Sir, please,
Please
Michael.
raise up your hand. Carry on.
Michael, yeah.
Michael, yeah.
I kindly want to call on your listening again to because I didn't got hold question regarding the layers. You I think you were trying to explain it, but I need a little clarification on it.
Okay.
How do we get
God told he wanted to find out. He wanted to relate to the layers that we have one layer. There's another layer on top of it. How do we get the layers? Are you okay?
Yes, sir.
All right.
Yes, sir.
Now remember that I didn't, at a point I was saying data layers. Data layers. In other words, when you have a satellite layer for AITC view where this campus is,
yes, sir,
that would be one layer. Okay. Okay. So where did we get a satellite from? You get it. Satellite imagery. We got a satellite imagery from remote sensing, which you are seeing on the board as a data source for GIS. That's what I said just right now. Does it make sense?
It does. It does.
Yes. So what you get from remote sensing is a satellite image. When you look at this corner, this bottom corner here, you get a picture on the ground.
Yes.
Okay. On this picture, we can put another layer on top of it. Maybe we're doing something within the area and we want to see, in context. So we use this as a background. So normally images are used as a background layer in GIS. So I think this should explain. Okay. What we're talking about. So layers always give you.
So sir.
Yes.
So sir.
Yes.
So sir.
Yes.
So sir. Hello sir. Please,
Yes.
I want to ask you. I want to ask you. So the layers, I understand the layers. So the data source that you are using, surveying, photogrammetry, and remote sensing, and then
photogrammetry. Hey, my friend, take it easy. Photogrammetry. Photogrammetry. Hey.
Okay. Photogrammetry. This
photogrammetry. Photogrammetry. Take a pen.
I'm not okay.
When you are in a lecture hall, you take a pen and you write things down. Don't be saying things like that. Go ahead. I'm listening to you. Yeah.
So these data sources, are you going to use the data sources to, let's say that the same area that you are using the survey? It is the same area that you are going to use the remote sensors to do.
Okay, so these are the sort of questions I'm asking you in exam. So I like it, the way you're thinking. It depends on the situation. Are you okay? So I think this week the assignments you get will be in that line so that you see when do I need this one, when do I need that. But one of the reasons why you use photogrammetry is when probably there's a fire, a wildfire, something like that in Australia. Ghana, we don't see those things. Some serious fire, people are evacuating. You can't task the satellite to go and look at the place and measure. Are you okay? Engineers measure before they decide. So in that case, would you use remote sensing? Maybe the satellites cannot reach that place. Scan it. Normally, the satellites move from place to place. Okay, you can't tell it quickly go back to Accra to go and take a picture. That kind of thing. So you realize that surveying to the place is on fire. Are you okay? You can't send whose son are you going to send to go and measure with a total station at that time when there's fire everywhere, like the circle fire. Do you remember the circle fire? Was it 6th June or something like that? 3rd June. Yeah, such a catastrophe. So at that point, the method is dependent on the convenience. Are you okay? Convenience. I think your question is almost like that. Anna, is your question not like that? Is your question in that
It's
line?
like maybe can you use the same data source like the surveying and all those things for the same area? Can you use the same?
No, why would you? They are expensive. Hold
Okay.
it. What you are saying, are you aware there are cost implications? So in every engineer should be taught there's something called cost benefit analysis and economic use. Otherwise, engineering is not engineering. So remote sensing, you know how much millions of dollars. You know how much you're going to pay? Thousands of that. So to get one image, so you don't can I use it for the same place? Okay, it means you are Bill Gates. Are you okay? So you are so rich that you can just be using different methods. So normally you use one method to get your data and probably see if you can complement it. Are you okay? With another one, but it should minimize costs. In fact, cost is a very important thing. Even though I'm not talking about it, but you should know that that's something fundamental in engineering. That you should always go for a method that is, optimal. Yeah. So you should consider. Yes. Correct.
It can it also be looked at in this way, like how expedient you need the information, the data, the how quick you need the data,
Yes.
which will also help you to inform you as to which type to use or which
so are you talking about agency? The
agency of the data required for that particular project.
So safety, we can look at agency, you can look at safety. They should inform you which one you go for. But first you should know how they work, then you know which one to go for, isn't it?
Yes, sir.
Yes, because there was a minister on TV, and I think she wanted to, long time ago, and she wanted to talk about remote sensing. I was sitting behind the TV and I knew she just wanted to talk about it, but she couldn't even describe it. She said there's something in the sky. Oh, and the way she was saying, I was like, my goodness. You see, so sometimes you learn so that it can help you to even decide, not to even use it, but you know that this is how this works. At the moment, this is what we need, not that. Yeah. Are we good?
Yes, sir.
Hello, sir.
Yes, go ahead.
For instance, I know of this friend about these projects on this railway line that they wanted to get the alignment of the rail line from Accra here, Ajin Kotoku to Winnie Valley.
Yes.
But I realized that they just wanted to know the existing alignment and know whether the redesigning they have to consider the existing. It's something like this. Using the GPS and like photogrammetry, I think you need to consider which one will give you the results.
Exactly.
Exactly.
Exactly. I do get you.
Yeah.
So you need to always choose. I think that's what engineering is all about. You need to chop. You need to choose. I think I'm hungry. You need to choose. Is that okay? You need to choose.
Please, we can't do 4 hours.
Oh, no. I will end it right now. I'll end it right now. We are ending the lecture.
Yeah, yeah.
I'm tired.
Sure.
Yes.
Sure.
So you need to decide which one you go for based on the teacher. And I think some of the questions that I'm asking in the exams are like that. They are looking at you applying that common sense to it and saying, no, I understand how this works. It won't fit into this scenario. And I think these are some of the difficult questions that students face when I set the questions. They are always looking very practical like that. So you need to really understand how the thing works. If you don't, you wouldn't know. Are you okay? Signals from, you need to first know something about the physics of a transmitter. Are you okay? Transmitters send signals in like, they are that fast, like the speed of light. So that is why your phone can quickly get your coordinates and keep on updating it, So you're driving and you are getting, as you go, different satellites are working out your location. That's how GPS is working. Meanwhile, remote sensing, he's up there, a lazy satellite, let me just put it that way, slowly moving and taking pictures. So you have to see the difference between the two. One is getting pictures, the other is getting coordinates. I mean, they are not on the same, wavelength. You can't put them. Okay. But remote sensing, when you look at, yes.
Remote sensing, is it an individually acquired something or is a national property?
Remote sensing.
Yes.
Remote sensing, there are organizations. Are you okay? There are different countries have their own satellites up there. Normally, it's a national effort. It takes a national effort to have a satellite up there. And then there are private organizations that are rich enough to launch their own satellites into the sky. And then it starts collecting data. They sell it. In fact, they are not there they are not for that Christmas. Are you okay? They sell it. An example is what you're looking at, GI. GI they have a satellite called GI. They've launched it into the sky and it can, it has a swath width of 15 kilometers. So over 15 kilometers, it takes a picture. Are you okay? And then it stays up in the sky for like 10 years to be up in the sky before it becomes space debris. Yes, before it becomes space debris. And so the information on it is what you are seeing here. Revisit time is 3 days. So it will only come to your area again in 3 days. That is what the revisit time is. Are you okay? The orbital altitude is 681 kilometers. So you can compare this one with the 11,000 nautical miles. You can see that this one is very close to the Earth, isn't it?
Yeah.
Okay.
Yeah.
Then we have other parameters. What is interesting, let's keep nodal crossing. The spatial resolution is 1.65 meters multispectral and 0.541 meter. Do you know what this means? This means that objects that are smaller than 0.5 meter, half a meter, cannot be seen. Objects that are less than. So for you as an engineer, you need to understand what we call resolution. Exactly. It determines how the smallest object that can be represented. All right. Now it also has what we call the spectral range or spectral resolution. So spectral resolution talks about the colors that the camera is taking. Okay. When we used to have black and white camera, there was something that we're missing, isn't it? You could never tell whether a person was fair or dark.
Yes.
Skin. You could never tell what, all the pictures look the same. So when you saw the picture from a friend's, grandmoms, they look the same as your auntie. It's like as if they are even sisters, but they were really looking different. Why? Because the camera was only sensing from the black and white range, of the electromagnetic spectrum. It means it was actually not sensing red, blue, and green, all right, which have a certain what? Frequency, wavelength. So now what you're seeing there is a wavelength, 450 nanometer. Is that okay? Anyway, I'm not getting so deeper into this. I want you to just appreciate what remote sensing is. That's why I put that there. Okay. So remote sensing, I'm ending on this. This is the end of the lecture. Let me run up on this one. Remote sensing requires that you have a target. The target is the area where you want to take the imagery. There should be a sensor. The sensor is where, okay, who can answer that question? Let's make this interactive. Where is the sensor for remote sensing? Got told. Where is the sensor remote sensing? He's asleep, eh? Michael.
No, I'm not sleeping. I'm thinking.
Okay. Oh, you're thinking. Okay. You should have told us. Okay, Michael, what's the sensor? Remote sensing. What's the sensor? What is sensing something?
So you mean where is it or what is it?
What is the sensor in remote sensing? Okay, let me give you a clue.
Sir,
Let me give you a clue. Let me give you a clue. Let me give you a clue.
Okay,
If you have, can you see this bottle? Can you see this bottle?
Yes, sir.
Yeah.
Can this bottle take a
Yes.
picture? Can it take a picture?
No.
No.
It can't. Okay. Can this phone take a picture?
Yes, sir. You can.
What's the difference
Yes,
between
sir.
what's the difference between the two?
The phone is a sensor.
It has a sensor, yes. It has, that's why. So what's the sensor in remote sensing? Where is it?
The camera. The camera.
Where is it?
It's the camera, the one that.
Where is it?
Where is it?
Where is not what? Where is it?
Behind
Where is
the
it?
phone.
No, remote sensing. I'm only using it to help you. Those move away from this. In remote sensing, where is the?
It's at the bottom. It's at the bottom of the.
Of the what?
Because it is taking, sir, because
Yes.
it is taking the picture from up and taking the earth sort of.
Where? So where?
Underneath.
So where?
It's either, it can either be on the satellite.
Thank you. Thank you. It's on the satellite. It's on the satellite. You can't fly an airplane outside the skies. At a certain height, you can't fly an airplane. I hope you're aware. So it's on the satellite.
So is it not under it rather, sir, or on it?
What I wanted to know is the word satellite. It's on it. Whether it has been bedded under it or on top of it. Are you okay? But I want the keyword satellite. So it's
satellite,
not it's not on an airplane. It's not on a helicopter. It's on a satellite. Okay, it's mounted on it.
Okay.
Okay, but it will be under it, as you say, to be under it. To be under it. What's the source of radiation? What's the source of energy? Okay, when you use the phone to take a picture, what are the conditions? If you take a picture, when you take a phone to take a picture, what should be there so that you can get a picture?
There should be light.
An object.
There should be the object. Second one, what should there be? What should be there?
Light.
There should be light. What's the source of light?
Should be light.
Either
the
from the
source?
sun or from the
Thank you,
flash.
thank you very much. So the source, I've already sent with the other guy. The source was sun, FO, CV403. So the source is the sun. Is that okay? The source of radiation is the sun. Okay, so I hope we are getting the idea. So the signal, the source, the sun emits energy, it interacts with the object on the ground, then the sensor now picks it. In fact, anytime you are taking a picture or a selfie, remember, that's what you are doing. You are sensing the reflection of the sun. Except if you use a flash. Are you okay? It's only a flash makes the difference. Okay? So in the 7 processes of remote sensing, there's an energy source, a radiation, so the energy interacts with the atmosphere. Then you have an interaction also with the target. Then it gets recorded on the 10 for now, 11 for now. So there should be a recording of the energy in the sensor, which is on the satellite. Then there's a transmission to the ground. Then we can receive it. It can be shared. Are you okay? So the satellite images are always received from the service providers. Okay, those who provide that service. All right, then you can now look at what do I do with the satellite image. In fact, sometimes when I give you a satellite image, you can't even process it. Can you imagine that? So, but then launching the satellite requires another project on its own, multi-million something. Okay, Ghana, I think we've launched our own satellite, isn't it?
Yes.
Yes. Is that good to say?
I don't know where it is, so maybe I don't know.
I know where it is.
Hey, go to where is it?
Where is the satellite?
It's around.
For security reason.
Oh, which security reason? Well, the public knowledge, Master.
Oh,
okay. All right. Okay. Guys, the lecture is still. We are running up. So application area. I'm showing you this one so that you can think about it. It's helping us to identify pathogens are disease-causing organisms. So pathogen infestation. An image that tells you how powerful remote sensing is. If our remote sensing can help us to, it helped us to determine in research that plants sleep at night. You know, someone was able to use remote sensing to determine that in the night, plants tend to lower their leaves a little bit as if they are sleeping. The same way, you know, can you imagine that? Remote sensing can help us to determine if there are rodents in your area. I mean, seriously, I believe that it's possible to do that. Okay, so the sun, the interaction, back to the sensor. The sensor has channels or bands that records red, green, blue, are you with me, etc. Okay, so we brought our lecture to an end. Any question? Otherwise, we are about to say goodbye to each other on this one. Satellite imagery, interesting stuff. I think we already talked about GPS. Did we talk about GPS? We have, haven't we? Yes.
Yes.
So it shouldn't be coming up again. Yes. Okay. So guys, any question for me? If you don't have a question, I think
we don't have this like.
We don't have the lecture notes.
Okay, let me drop it. I'm going to drop it right now. So don't worry about it. Yes.
And then the video, and then the videos.
You'll get a video, yes. Now, as for the video, subscribe to the channel. I can't be dropping it. Subscribe to the.
It's not the YouTube one. It's not the YouTube. It's not the YouTube one that I went there. I couldn't find it. You know.
You couldn't find it. Hey. Wow.
It's not the YouTube this thing. I went there.
You couldn't find it.
I saw you posted some pictures, something, but I couldn't find the video.
I told you that yours will always be the latest. Is that okay? In terms of the videos you see on the channel, I shared it with you, isn't it?
I went, I visited that particular, I subscribed and they asked my.
The videos you found there were not what you were expecting.
No.
Oh, okay, we'll work on that. Sorry about that. Okay. I'm sorry about that.
Hello, sir.
Yes.
So the Google map, is it as a result of the remote sensing, the source?
Google Map is a GIS on its own. So when you go to when you see Google Map, you have seen a GIS software. But you see, software, people think our software as something someone put on a pen drive and give to you to go and install. No. There are software that run on the internet. Okay, they are called web applications. In fact, there's also what we call cloud computing, where you can do things without them being on your computer per se. So that is what Google Map is. And the good thing about it is that the whole world can access it. The benefit of the internet is that we can all be connected. Is all right. So Google Earth, Google Map, they are all there as web GIS. They are web GIS. So I've asked questions on that before in exams. So it's a very good contribution you are giving right now. Yes, Google Map, they are all GIS. If If you look at it, you can search for what is at a certain place, isn't it? That query, okay? You can do the query. So anytime you're using Google Map to find a place, remember that you are doing what? GIS. So GIS is closer to us than we think. GIS is closer than we think. We are using GIS every day, but we are not even aware. You know, they have apps that allow you to like determine how far you have walked or something like that, like fitness apps.
Yes.
Yes. I'm even developing one right now, a fitness app. I'm not trying to sell my products. Are you okay? I'm not trying to sell my product, but I have to bring it in. I have to bring it in. You see, this is a channel.
Sir.
Were you
These are
here?
the things that I saw then. So, well, yeah, I was here.
And you didn't see the videos. You were here, didn't see the videos.
I saw the pictures, but I didn't see them.
The videos are there. These are the videos.
I thought it was pictures, so I didn't click on them.